We now discuss the numeric value type questions that have come from the section Quadratic Equations. These questions have appeared in the joint entrance examination main in the January 2024 session. These examinations were held from 27th January 2024 to 1st February 2024. We now discuss the first question. This question has appeared in the joint entrance examination main held on 31st January 2024 in the second shift. The given question is, let A, B, C be the lengths of three sides of a triangle satisfying the condition a square plus b square in brackets multiplied by x square minus 2b multiplied by a plus c in bracket multiplied by x plus in brackets b square plus c square is equal to 0. If the set of all possible values of x in the open interval alpha to beta, then 12 times in brackets alpha square plus beta square is equal to. We are given A, B, C are the lengths of three sides of a triangle satisfying the condition. The condition is given through a quadratic expression. This is the condition. Now, if the set of all possible values of x that come from the open interval alpha comma beta, then required to find the value of 12 times in brackets alpha square plus beta square. We now discuss the solution of the problem in detail. Given A, B, C are the lengths of three sides of a triangle, and these lengths satisfy the quadratic equation a square plus b square multiplied by x square minus 2b into a plus c into x plus b square plus c square is equal to 0. Agreed. Now let's take this quadratic equation and simplify. This is written as a square x square minus 2abx plus b square, that's in one bracket, plus b square x square minus 2bcx plus c square. So the first one is a perfect square. It is ax minus b whole square. And the second one is also a perfect square, that is bx minus c whole square. That's equal to 0. The sums of the squares is equal to 0, then each one must be equal to 0. This will imply ax minus b is equal to 0 and bx minus c is equal to 0. This will imply x is equal to b by a and x is equal to c by b. This implies x is equal to b by a and x is equal to c by b. When multiplied, we will get x square, b cancels, b by a multiplied by c by b cancels, and you will get c by a. X square is equal to c by a. We continue the discussion in the next slide. Right, that's what we have done so far. We are given A, B, C are the lengths of the three sides of a triangle. This condition we have not used. Let's use now. Now, we have the triangle inequality. The triangle inequality says the length of any side of a triangle is less than the sum of the lengths of the other two sides. And that is b less than modulus of a plus b. And further we know b is greater than modulus of the difference of the lengths of the other two sides. That is b greater than modulus of a minus c. Thus we get modulus of A minus C less than B less than A plus C. Now divide throughout by A, then you will get A minus C by A, that is mod of 1 minus C by A less than B by A, yes, less than A plus C by A, that is 1 plus C by A. Now we write down for C by A x square, and for B by A, we write x, we write this x. So this will be, this implies mod of 1 minus x square is less than x is less than 1 plus x square. Right. We write down as two inequalities. The first inequality is x less than 1 plus x square. This is the inequality that we have written in red. And the second one is modulus of 1 minus x square is less than x. That is the second inequality what we have written in blue. Let us take the first one. That is x less than 1 plus x square. Then this will be x square minus x plus 1 greater than 0. Is a quadratic equation greater than 0. And this we say that this is true for all values, for all real values, x belongs to R. How it is? It is written as x square minus x plus 1 is equal to x minus 1 by 2 whole square. That will give you x square minus x plus 1 by 4 To adjust the term 1, then we have added 3 by 4. So that is greater than 0. So for all x belongs to R, this is positive. This is always positive. So the first one is true. That is x less than 1 plus x square is less than x less than 1 plus x square is true for all x belongs to R. So we go for the next inequality, that is in blue. Mod of 1 minus x square is less than x. So when 1 minus x square is positive, then mod of 1 minus x square is 1 minus x square less than x. And when 1 minus x square is negative, mod of 1 minus x square is minus of, in brackets, 1 minus x square, that is minus 1 plus x square less than x. So the first one will give you x square plus x minus 1 greater than 0, and this will give you x square minus x minus 1 is less than 0. So these are the two inequalities what we got, and we'll discuss further in the next slide. Agreed. So that is the x square plus x minus 1 greater than 0 and x square minus x minus 1 less than 0. Now let's take the equation x square plus x minus 1 is equal to 0. It's a quadratic equation. Ax square plus bx plus c is equal to 0. Solve for x. X is equal to minus b plus or minus under the square root of b square minus 4ac by 2a. Substituting the appropriate terms, then you will get two roots minus 1 plus or minus root 5 by 2. One you call it as alpha, that is minus 1 minus root of 5 by 2 as alpha, and the beta is minus 1 minus root of 2 by root 5 by 2. And in the second case, x square minus x minus 1 less than 0. Take the quadratic equation, x square minus x minus 1 is equal to 0. Solve for x, then x will be minus b plus or minus under the square root of b square minus 5 by 4, b square minus 4ac by 2a. That will give you 1 plus or minus root 5 by 2. So one of the roots you call it as alpha, the other is beta. In this also one is alpha, the other is beta. Right. Now let's recall. In this case, x minus alpha into x minus beta greater than 0, where alpha less than beta. Alpha is minus 1 minus root 5 by 2. Beta is minus 1 plus root 5 by 2. Alpha less than beta. Then x belongs to the union of two intervals, that open intervals, minus infinity to alpha union the open interval beta to infinity. Beta to infinity. Minus, open interval minus infinity to alpha union the open interval beta to infinity. And even in this case also, it will be x minus alpha into x minus beta, where alpha less than beta. Then because it is less than 0, x square minus x minus 1 less than 0, this is less than 0, the above one is greater than 0, then x will belong to the open interval alpha to beta. Alpha is this small root and beta is the bigger one, bigger than alpha. Now let us see for this x belongs to minus infinity to alpha union beta to infinity. This is the one for from this and from this x belongs to alpha, the smaller one, 1 minus root 5 by 2 comma 1 plus root 5 by 2. So this is using this inequality, and these two roots you can write down using this one. These two results which we know from our earlier classes, right? Because it is the end, the intersection. So x belongs to the union of these two intervals, intersection this open interval, right? Now see how these roots are. This is note that minus 1 minus root 5 by 2 less than 1 minus root 5 by 2. This is negative. Is less than minus 1 plus root 5 by 2. This is positive. Less than 1 plus root 5 by 2. Let's look at them on the real numbered line. This is the real numbered line. First, let us see this one. This is minus 1 minus root 5 by 2, and this one is minus 1 plus root 5 by 2. And x belongs to the union of the intervals. So this is minus infinity to alpha, and this is beta to infinity. Minus infinity to alpha and beta to infinity. This is the union. This one is depicted in red. The intersection 1 minus root 5 by 2. Where is 1 minus root 5 by 2? Here is 1 minus root 5 by 2, and 1 plus root 5 by 2 is here. And it belongs to the open interval from 1 minus root 5 by 2 to 1 plus root 5 by 2. Let's locate that. So it belongs to this one. So what is the commonality? What is the common between these two? From this diagram, the common is the open interval minus 1 plus root 5 by 2 to 1 plus root 5 by 2. So the intersection, that is the commonality, is equal to minus 1 plus root 5 by 2 comma 1 plus root 5 by 2. This is given to be alpha comma beta, where alpha is minus 1 plus root 5 by 2, beta is 1 plus root 5 by 2. So required to find 12 times of alpha square plus beta square. First we compute alpha square plus beta square, alpha square plus beta square. And this is 2 into a square plus b square, 2 into minus 1 whole square 1 plus root 5 whole square 5 by 2 square, that is 4. So this is equal to 3. And required to find the value of 12 times alpha square plus beta square, that is 12 times alpha square plus beta square, which we have seen above. 12 into 3 is equal to 36. That is the required answer. The answer to this question is 36. That is the detailed discussion of the solution of the given problem on quadratic equations. I am sure that you have understood the solution of this problem. Let's now move to the second question. This question has appeared in the Joint Entrance Exam Main held on 30th January 2024 in the second shift. The given question is the number of real solutions of the equation x times in brackets x square plus 3 times mod x plus 5 times mod of x minus 1 plus 6 times mod of x minus 2 bracket close is equal to 0 is. We have to count the number of real solutions of this equation. Let's now discuss the solution of the problem in detail. We have the given equation, this one, x into, in brackets, x square plus 3 times mod x plus 5 times mod of x minus 1 plus 6 times mod of x minus 2, bracket close, is equal to 0. Let's call this as the equation 1. This will imply x is equal to 0 and the second factor is equal to 0. So this means x is equal to 0 is a solution of the given equation 1. Now, are there any other solutions? If at all there are any other solutions, they will come from the second factor is equal to 0. So let's look for that one. Now, you take any value x belongs to R. For any x belongs to R, the left hand side of this equation is always positive. This will give you a positive number is equal to 0, which is not possible. So that means no real value will satisfy this equation. So now consider the second factor is equal to 0. Call this as the equation 2. Note that for any x belongs to R, that means for any real x, the left hand side of this equation 2 is a positive number. A positive number is equal to 0 is not possible, is not true. So this will tell you that is no real number satisfies this equation 2. Therefore, no real number is a solution of the equation 2. Therefore, we have only one solution, that is x is equal to 0. So this implies x is equal to 0 is the only real solution of the given equation 1. Therefore, the number of real solutions of the given equation is 1. So the answer to this question is 1. That is the detailed discussion of the solution of the problem from the section Quadratic Equations. I am sure that you understood the solution of this problem. Let's move to the third question. And I think this is the last question under integer value type questions. This question has appeared in the joint entrance exam main held on 30th January 2024 in the first shift. The given question is, let alpha beta be natural numbers, be roots of this quadratic equation x square minus 70x plus lambda is equal to 0, where lambda satisfies this condition. Lambda by 2 comma lambda by 3 does not belong to the set of natural numbers. That means lambda by 2 and lambda by 3 are not natural numbers. If lambda assumes minimum possible value, if lambda assumes the minimum possible values, then you have to compute this one, that is in brackets root of alpha minus 1 plus root of beta minus 1 bracket close multiplied by lambda plus 35 in bracket whole by mod of alpha minus beta is equal to. We are given a quadratic equation x square minus 70x plus lambda is equal to 0, and it is further given alpha beta are the roots of this equation, where alpha beta both of them are natural numbers. It is further given this lambda satisfies lambda by 2, lambda by 3 are not natural numbers. And if lambda assumes the minimum possible value, then required to find the value of in brackets root of alpha minus 1 plus root of beta minus 1 bracket close multiplied by lambda plus 35 whole by mod of alpha minus beta. Let's now discuss the solution of the problem in detail. Given alpha beta are natural numbers, and further they are given they are the roots of this quadratic equation x square minus 70x plus lambda is equal to 0. Now the sum of the roots alpha plus beta is equal to minus the coefficient of x by the coefficient of x square, that is minus of minus 70, that is plus 70. The product of the roots alpha beta is equal to the constant term lambda divided by the coefficient of x square, that is 1, that is lambda by 1, lambda only. Thus we got alpha plus beta is equal to 70 and alpha beta is equal to lambda. We are given lambda by 2 and lambda by 3 are not natural numbers. What is the meaning of this? The meaning of this is 2 and 3 are not divisors of lambda. That means 2 and 3 does not divide lambda. But lambda is equal to alpha beta. Therefore, 2 and 3 does not divide the product alpha beta. And 2 and 3 does not divide alpha beta. 2 and 3 are relatively prime. Therefore, 2 and 3 does not divide A alpha. And 2 and 3 does not divide beta. Agreed? Agreed. Now, we now enumerate the least possible values of such alpha beta. Such alpha beta mentioned above. That is 2 and 3 does not divide alpha and 2 and 3 does not divide beta. Right. Now, if we take alpha is equal to 1, then alpha plus beta is equal to 70 will give you beta is equal to 69. But beta is equal to 69 is divisible by 3. But what are the properties of alpha and beta? 2 and 3 does not divide alpha, 2 and 3 does not divide beta. Therefore, we reject this choice. That is alpha is equal to 1, beta is equal to 69, we reject it. Now, suppose we take alpha is equal to 2. We can't because 2 and 3 does not divide alpha. So, alpha is equal to 2 is not possible. Alpha is equal to 3 is not possible. Alpha is equal to 4 is also not possible because 2 divides 4. 2 divides 4. So, that therefore, alpha not equal to 2, alpha not equal to 3 and alpha not equal to 4 since 2 and 3 does not divide alpha. So, the least one is alpha is equal to 5. When alpha is equal to 5, alpha plus beta is 70 will imply beta is equal to 70 minus 5, 65. Now see, 2 and 3 does not divide alpha, 2 and 3 does not divide beta, that is 65 also. So these are the least possible values of alpha beta. Therefore, the least possible value of lambda is equal to alpha beta. The least possible value of alpha 5 multiplied by the least possible value of beta is 65. The product is 325 and this will be the least possible value of lambda. So we got this one. So lambda assumes the minimum possible value. So is the least possible value we have taken and we have to compute this one. So now let's compute in brackets root of alpha minus 1 plus root of beta minus 1 bracket close into in brackets lambda plus 35 by mod of alpha minus beta. Substitute alpha is equal to 5, beta is equal to 65 and lambda is equal to 325 in this. So this is the substitution what we have made. And under the square root of 5 minus 1, square root of 4, that is 2, square root of 65 minus 1, square root of 64, that is square root of 8. This is 2 plus 8. 325 plus 35 is 360. And by modulus of 5 minus 65, mod of minus 60, that is 60. So that is what we have. 60 cancels in 360 6 times. 2 plus 8 is 10. 10 into 6 is 60. So that is the value of the given quotient. So the answer to this question is 60. That is the detailed discussion of the solution of 3 numerical value type questions from the section quadratic equations that have appeared in the joint entrance examination main in January 2024 session. I am sure that you have understood the solution of this problem and I wish you all the best. Thank you.